define quadratic formula, another if-then statement. So again, our quadratic has to be in this form, specifically must be in that form to use this quadratic formula. Once we have it in that form, we can use this formula to come up with those x values that make this equation true. All right, so now again, you don't have to memorize these formulas, you just need to be able to use them correctly when asked to. So we'll use that, and this is like the zero factor property is not always applicable. We can't always use that. Sometimes we can factor a trinomial into the product of two binomials, sometimes we can't. Square root property. Sometimes we can use it when we don't have an x term. If we have an x term, then we can't use the square root property. The quadratic formula, if you can form this, and it doesn't matter whether you have an x term or not, if this isn't present, then the b is 0. Right? If there's no x term, then b is 0. So anytime you have a quadratic, this will work, anytime. Okay? If you can put it into this form and put those a, b's, and c's into this formula, the quadratic formula will always work for you. So if you're just asked to solve a quadratic equation and you're not told what method to use and you are left to choose, this one will always work. It's not always the easiest, but it will always work. So in this case, we're looking at number 66. And it says x squared plus 8x plus 12. So again, nicely, this is already in the proper form. This is number 66 on page 161. And this is already in the form that we want. Right? If it's not in this form already, then that's the first step, is to put it into that form. Now that we have it in that form, we just want to identify what the A is, what the B is, and what the C is, so that we can then put it into this formula and come up with the solutions. So here we see that A is 1, B is positive 8, and C is positive 12. Right? The number in front of the x squared is 1, the number in front of the x is 8, and the constant term is 12. Now, be careful with the positives and negatives, right? A lot of people, if it's negative here or here, they'll forget to put the negative with the value. So take the positive or negative with the A, B, or C. These happen to all be positive, so there's no problem there. So now we can just start to plug this in, that A, B, and C into this formula, simplify, and get our answers. So negative B plus and minus B squared minus 4AC over 2A, just to put everything in there, right? You don't have to, you can take a little shorthand cuts within here, but this is, since we're explaining it, I'm putting each and every value in. Right? Negative B plus and minus B squared minus 4AC over 2A. So let's simplify the number underneath the square root here first. So we get negative 8. And this is 64 minus 48. So nicely we get a perfect square there. That's not always going to happen, but that's nice. So now we can just convert that to 4, right? Square root of 16 is 4. So now we're going to use this idea where if we have the sum or difference over one same denominator, we can break that up into two fractions. We're going to use that here, using this idea over here. We're going to break this up into two parts. Negative 8 over 2 plus and minus 4 over 2. And those are nice, easy numbers to figure out. So we finish that off and say negative 4 plus and minus 2. So we get two answers. Negative 4 plus 2 gives us negative 2, and negative 4 minus 2 gives us negative 6. And if you're writing your answers on paper, always try to circle them, label them, so there's no confusion about what your answer is. All right, and again, you can always check these answers, put these values back into the original equation, make sure that they come out. If they don't give you a true equation, then we made mistake somewhere, and you want to go back and fix those things. Pretty sure that one's right though. And this is, again, when you get two real answers like that, that's the case where the parabola is crossing the x-axis in two spots. We're finding those spots where it crosses the x-axis. All right. Again, that one can always be used. That's always reliable as long as you have a quadratic equation. All right, and the last method. Oh wait, one more thing I want to mention about the quadratic formula. Okay, so remember this was the full formula. This part here, just the part that's underneath the square root, has a special name. It's called the discriminant. Let it be a capital D so we can shorthand it here. But the discriminant has a special role in telling us how many solutions. Remember, there's either going to be one or two solutions to all these quadratics, and what type. Remember, we had real solutions or imaginary solutions. So the three choices for when the question is how many and what type of solutions to a quadratic, to any quadratic, the three possible answers are two real solutions, two imaginary solutions, or one real solution. Remember, those were the three possibilities. So the discriminant will tell us which of those three possibilities we have for any quadratic. So let's use the last one that we just looked at, number 66, which was x squared plus 8x plus 12. And we said A was 1, B was 8, and C was 12. So if the question for this one, we already know that we got two real solutions for this one, so we're just going to try to match that with the discriminant here. The discriminant for this is b squared minus 4ac. We already figured out what that was. Let's just look at it again. We came up with 16 here, right? 64 minus 48. Remember your order of operations. You're going to do multiplication before you do the subtraction. So we get 16. So if the discriminant is greater than 0, then we're looking at two real solutions. If the discriminant is less than 0, then we're looking at two imaginary solutions. And if the discriminant equals 0, that's the case where we have one real solution. So when you're asked how many and what type of solutions, you don't have to go through the whole, so you can go through and find the solutions like we did in the previous example, and that will tell you if you had two real, two imaginary, or one real. But this is a little quicker, less work, less computation. All you got to do is look at the discriminant. All you care about is it positive, is it negative, or is it 0? So in this case, it's greater than 0. So we're looking at the two real solutions, which agrees with what we did a couple minutes ago. All right, so know how to find solutions, actual solutions using the quadratic formula. Know that the discriminant is the term underneath the square root, and know what the discriminant tells you about the quadratic equation. All right, one last method in 1.5 is completing the square. Now, completing the square is kind of a lesser used method, but it's very important because it comes up again in future chapters. So when we talk about circles and ellipses and chapter 7, conic sections, this comes up again, so don't ignore this. We're only going to kind of use it a little bit in this section, but it does come up in the future. So completing the square, there's two distinct kind of cases here. So let's look at which one I wanted to do. Number 48. Let's look at number 48 on page 160. And this is again another example of a quadratic equation. Notice the highest exponent is 2. We do have a x term here. So the first thing, generally, we said we wanted to put it into that standard form of ax squared plus bx plus c equals 0. For this method, we're going to put that c value on the other side. Okay? So if it's not in this is the form you want to start with when you're completing the square. You want the ax squared term and the bx term on one side, and the constant term you want to put on the other side. Okay? And another caveat here, and we'll do an example of this next, but in front of the x squared has to be a 1. Okay? If there's anything other than a 1 in front of the x squared, then you have to factor that out before you go on to complete the square. In this case, we do have a 1, so we're okay. We can start with the method of completing the square. So what we're doing, the reason it's called completing the square, is because we're going to add something to this side of the equation. And obviously, if we add something to this side, we have to add to the other side also. But we're going to add something to this side to get a perfect square trinomial. We're going to create a perfect square trinomial, which will then factor into the product of two binomials. And then we'll be back to the square root property, and we'll be able to solve the equation that way. So that's what's going on with completing the square. We're going to use a method to determine what we need to add to this side to create a perfect square trinomial. Then we're going to factor it into two binomials, and then we're going to have the product of two binomials equaling a number, which is the square root property if statement, and then we'll be able to solve that. So what you do is you identify the b term first. So our b term is 6. All right, remember, we're looking at it like this now. ax squared plus bx, and we put the c term on the other side. Don't worry about the sign of the c. It can be positive or negative. In this case, it happens to be negative. So the b term is a positive 6. So you identify what that b term is. You take half of that, and then you square that number. You take the half of the b that you found, and you square it. This is the number that we're going to add to both sides of the equation to create a perfect square trinomial over here. And of course, we have to balance the equation on the other side. So now, let's come over here. So now we're going to add that number, 9, to the left-hand side. And again, obviously, we have to add it to the other side also. So what we've done by adding that 9 to this side, really what we've done is it's the reverse of the FOIL method. Instead of taking a trinomial and factoring it into two binomials, we've used that method to create the number that we have to put here so that we can use the FOIL method reverse factoring technique to get this to be the product of two binomials. And this number adds up to 1. So now this is, again, in the prerequisite chapter, how to factor a trinomial using the trial and error method. We did this earlier. We take the x, it's 1x squared, so we know our only choice for the first terms is x and x. We want factors of 9 such that we can get factors of 9 such that we can get a 6. Now remember, we're creating a perfect square here, so the number is going to be the same because it's a perfect square, just like square root of 4 is 2. 2 times 2 is 4. This is going to be the same thing here as here. Right? Now remember perfect square trinomials, this number is a perfect square. It is, it's 3. This number is a perfect square, 1. It's a perfect square, is 1. So the square root of this number is what you're going to put over here. Right? It's all pluses, so we're going to put plus and plus. And again, we can always check. X times x is x squared. We got 3x on the outside, 3x on the inside to add to the middle term. 3 times 3 is 9. So what we've done is we've created this situation. Right? We added 9 to the left-hand side to create this perfect square trinomial, which factors into a binomial squared. And now this is the if statement of the square root property. Right? So now back to the square root property. We can now take the square root of both sides. So we take the square root of the left-hand side, and remember the plus and minus of the square root of the right-hand side. Square root of 1 is still 1. And now, hopefully, it's pretty easy. We subtract 3 from both sides. And we come up with our solutions. Negative 3 plus 1 gives us one answer. And negative 3 minus 1 gives us our other answer. Again, always a good idea to check, put those numbers back into the original equation, and make sure that they're actually valid answers. So we got two real solutions here. If we were to use the discriminant property here, we would see that the discriminant is positive, giving us two real solutions. All right, so that is the completing the square method. There's one more case where, remember we said we have to have a 1 out in front of the x squared, so let's look at one case where that is not the case and we have to fix that. All right. And this is where you have to remember how to deal with fractions, because many times these things are going to involve a fraction. So let's look at number 60 on page 160. And so again, notice here we have a 2 in front of the x squared. That's the difference from our previous example. All right, so this one is set up in the general form of ax squared plus bx plus c equals 0. So our first step, we're being asked to use completing the square here. Quadratic formula will work here. You can try to factor this and use the zero factor property, but we're being asked to complete the square here. So first we're going to bring that 3 to the other side. All right, we add 3 to both sides of the equation. All right, so now we're almost to where we were here. We got to get rid of that 2. Okay, we got to get rid of that 2. So we got to factor that out. Now you're not just factoring it out of the first term, right? You're factoring it out of the entire left-hand side of the equation. So when you take a 2 out of 2x squared, we're left with x squared. When we take a 2 out of 5x, we're going to be left with 5/2 x. All right, 2 times 5/2, it gives you 5x, right? So we had to take that 2 out. That's the extra step here when we have a number, anything other than 1 in front of the x squared. So now we don't want this 2 sitting here, so we'll divide both sides by 2 to get rid of it. On the left-hand side, so we got this, just to be clear, and then over here, we now have 3/2, right? This side divided by 2 gives me this. This side divided by 2 gives me this. Now, we're right back to where we were. Just so happens that we have a fraction to deal with. No big deal, we're in college, we can deal with fractions, right? So, we go through the same method we did over here. Let's rewrite it here just so we have it. So now our b term is 5/2. Half of the b term, when you're taking half, all you're doing is doubling the denominator, right? So half of that b term is 5/4, right? 5/2 times 1/2 gives me 5/4. And we're squaring that term. 5 squared is 25, 4 squared is 16. So that's the number we're adding to the left-hand side and, of course, the right-hand side. So now we come down here and say x squared plus 5/2 x plus 25 over 16 equals 3/2 plus 25 over 16. Okay, so this is now our perfect square trinomial, which is going to factor into a binomial square. And let's get a common denominator here so we can add these together. If we put 2 goes into 16 8 times, so if we put everything over 16, 8 times 3 is 24, so we get 24 plus 25 which nicely gives us numbers that are perfect squares, which makes us think we did something right. We took that 2 out so that we'd have a 1 in front of the x squared, which leaves us no choice for the first term here. The number that goes here is always this number, okay? Always. It's always that number that we took to be half of the b term from the original equation set up this way. So 5/4, it's a positive 5/4. So that's what's going on here. So now our equation is x plus 5/4 squared equals 49 over 16. And if you recognize that, hopefully again, that's the if statement of the square root property, right? Just like we had over here. So now we're just going to take the square root of both sides and solve for our results. Take the square root of the left-hand side, and we take plus and minus the square root of 49 over 16. Hopefully we remember our rules of radicals. Square root of 49 over 16 is going to be just 7 over 4. Right, square root of 49 is 7, square root of 16 is 4. And now we're going to subtract 5/4 from both sides to get our result. So we're going to say negative 5/4. You can put that on either side, it doesn't matter, of the 7/4. Negative 5/4 plus and minus 7/4, which leads to 2 solutions. We get negative 5/4 plus 7/4, which leaves us with 2/4 or 1/2. And negative 5/4 minus 7/4 gives us negative 12 over 4, or negative 3. All right, good times.